Hello, my dear students. Welcome back to Fluid Mechanics lecture series. I am your SumamMiss. My channel name is also SumamMiss. You can watch all my videos on my channel. Today we are continuing the discussion on open channel flow. So in the previous session we have discussed different type of open channel. Open channel may be of natural channel and artificial channel. Natural channel, you can see from this figure that its cross section is varying from section to section and slope is also varying, and its surface roughness varies in wide range. Whereas artificial channel, that is also called man-made channel, having definite shape, it is also possible to maintain the same shape and slope throughout the length of the channel. So that type of channel is called prismatic channel. Artificial channel or man-made channel are available in different shapes. So the figure shows the channel of rectangular, triangular, trapezoidal and circular cross section. So in the previous session, we have also discussed the geometric elements and geometric parameters of different shape of this open channel. We have learned previously that the flow can be classified based on time as criterion as well as space as a criterion. If you are classifying the flow based on time as criterion, we can classify the flow into steady flow and unsteady flow. In steady flow, all the flow characteristics, that is the flow velocity and flow depth, are constant with respect to time. Whereas in unsteady flow, these flow characteristics are changing with respect to time. If we are classifying the flow as space as a criterion, then we can classify the flow as uniform flow and non-uniform flow. In uniform flow, we have learned previously that these flow characteristics are constant along the length of the channel. So uniform flow is generally possible in prismatic channel, where we are able to maintain the shape and slope constant throughout the length of the channel. Whereas if either of these changes the flow characteristics, then it will be creating non-uniform flow. So that means in non-uniform flow, flow characteristics, that is the flow velocity and flow depth, are changing along the length of the channel. In the last section, we have discussed about the uniform flow equations for the computation of velocity, among which one is Chezy's equation, that is V equal to C into root of R S naught, and another equation is Manning's equation, that is V equal to 1 by N R raised to 2/3 S naught raised to half. R is called hydraulic radius. It is the ratio of cross-sectional area to wetted perimeter, where S naught is the bed slope and N is Manning's roughness, whereas C is Chezy's constant. So this N and C are related to the surface roughness. That means C equal to 1 by N R raised to 1 by 6. The topic for today's discussion is the most economical or hydraulic efficient section of the channel. A channel section is said to be most economical or efficient section when it can pass maximum discharge for a given cross-sectional area and roughness coefficient and bottom slope. So discharge equation, that is equal to Q equal to AV. So for a given cross-sectional area of the channel, the discharge is maximum when V, that is flow velocity, is maximum. So equations available for the computation of uniform flow velocity is Manning's equation, that is V equal to 1 by N R raised to 2/3 and S naught raised to half, and other equation is Chezy's equation, that is V equal to C into root of R into S naught. For a given channel of non-roughness and bottom slope, velocity is maximum when hydraulic radius is maximum. R is maximum, or R, which is equal to A by P, that is maximum. Or we can say that P is minimum. That means a channel section is said to be most economical or hydraulically efficient when the wetted perimeter P is minimum. So compared to other cross sections, semicircular section has the lowest wetted perimeter and therefore is the section of highest efficiency. However, due to the practical limitations in maintaining this section, usually this trapezoidal section is employed. If the channel is to be excavated, the most efficient section will become the most economical, since for a given discharge, the area of the section is minimum. That is, the quantity of material to be excavated for the construction of the channel cross-section becomes minimum, which results in initial reduction in the cost. So that means we can say that hydraulically efficient section will become the most economical section. Now let us discuss about the most economical section of a rectangular section. A rectangular channel section is usually made in rocky soil where the faces of this rock can stand vertically. It is also employed in the forms of cement and concrete. So figure shows a rectangular channel with the bottom width B and floor depth Y. Area of the channel, that is equal to B into Y, and perimeter, that is equal to B plus 2Y. So we have learned previously that the discharge is maximum when wetted perimeter is minimum. So if you are replacing this B by means of A divided by Y, then we can rewrite the expression for P equal to A by Y plus 2Y. So the maximum discharge condition is minimum wetted perimeter. So the condition of minimum P is dP by dy equal to 0. So if you are differentiating this wetted perimeter with respect to y and equating into 0, is equal to minus a by y square plus 2 equal to 0. If we are rewriting, this becomes a equal to 2y square. If we are replacing a by means of by, so by equal to 2y square, or breadth equal to 2y, or depth equal to b by 2. So the condition of minimum wetted perimeter P for a rectangular channel to make it most economical or hydraulically efficient is the bottom width B, that is equal to twice the depth, or the depth Y equal to b by 2. Correspondingly, the hydraulic radius equal to R equal to A by P. A is by and perimeter P equal to b plus 2y. So if you are replacing b as 2y correspond to the most economical or efficient section, then hydraulic radius R equal to 2y square by 4y, that is equal to y by 2. So to conclude, for a rectangular section, the most economical or efficient section of the channel section is the bottom width B, that is equal to twice the floor depth. Now let us discuss about the most economical or efficient section of a trapezoidal section. A trapezoidal section is always preferred in earthen channel so that the side soil can stand safely. In soft soil, flattened side slopes are employed. So the figure shows a trapezoidal section having bottom width B, floor depth is given as y. Side slope is given as z horizontal to 1 vertical. So this distance, that is equal to zy, this distance also zy. So the top width t, that is equal to b plus zy plus zy. That means top width t equal to b plus 2zy. Similarly, this length of the sloping side pq, that is equal to pq square equal to y square plus zy square, or pq equal to y into root of 1 plus z square. So area of this trapezoidal channel section, that is equal to b plus zy into y, and wetted perimeter p, that is equal to b plus pq plus rs, that means b plus 2y into root of 1 plus z square. Now the constant b is replaced by means of a by y minus zy, and substituting, the expression for wetted perimeter is changed into p equal to b is now replaced by a by y minus zy plus 2y into root of 1 plus z square. So the condition of minimum wetted perimeter is dp by dy equal to 0. So if you are differentiating this expression with respect to y, then it becomes minus a by y square minus z plus 2 into root of 1 plus z square equal to 0. If you are rewriting this expression, it becomes a by y square plus z equal to 2 into root of 1 plus z square. Now a is replaced by b plus zy into y. That is b plus zy into y divided by y square plus z equal to 2 into root of 1 plus z square. If we are cancelling one y, then it becomes b plus 2zy by 2, that is equal to y into root of 1 plus z square. What is b plus 2zy? It is the top width. Y into root of 1 plus z square, that is one of the sloping side. So this we can write as t by 2 equal to length of sloped side. So to conclude here, for a trapezoidal section, the most economical or efficient section of the channel is half the top width equal to length of the sloping side. So we can express the bottom width b equal to 2y into root of 1 plus z square minus 2zy. Correspondingly, we can find out the hydraulic radius. Hydraulic radius r equal to a by p. A equal to b plus zy into y divided by b plus 2y into root of 1 plus z square. But the most economical section is b plus 2zy equal to 2y into root of 1 plus z square. So if we are replacing 2y into root of 1 plus z square by b plus 2zy, then simplifying, you will get hydraulic radius r, that is equal to y by 2. This is as same as that of rectangular section. In the next part, we are going to discuss about the most economical or efficient section of a triangular section. So figure shows a triangular channel section. Side slope is given as z horizontal to 1 vertical and floor depth is given as y. Length ps, that is equal to y tan theta, which is equal to rs. So the top width pr, that is equal to 2y tan theta, which is equal to ps plus rs, and the sloping side pq, that is equal to y sec theta. So area of this triangular section, that is equal to half bh, that is half into 2y tan theta into y. So the area of this triangular section, that is equal to y square tan theta. Vector perimeter p, that is equal to pq plus qr, that is equal to 2y sec theta. Since the channel cross section depends upon the value of theta, for getting the condition of the most economical or efficient section, we have to differentiate this vector perimeter with respect to theta for getting the minimum vector perimeter. So replacing y in terms of theta, y equal to root of a by tan theta. So if you are substituting this y here, then the expression for vector perimeter p equal to 2 into root of a by tan theta into sec theta. So the condition of minimum vector perimeter equal to dp by d theta, which is equal to 0. So if you are differentiating this expression with respect to theta and equating into 0, then this expression is 2 into root a into differential of sec theta by root of tan theta d theta equal to 0. So it is 2 into root a into sec theta tan theta by root of tan theta minus sec cube theta divided by 2 tan theta raised to 3 by 2. So if you are taking a common LCM and making numerator equal to 0, then you can simplify this expression like this. Then you can finally find theta equal to 45 degree or z equal to 1. So for a triangular channel section, the condition for most economical or efficient section of the channel is theta equal to 45 degree or z equal to 1. Hydraulic radius r also we can calculate r equal to a by p, that is y square tan theta divided by 2y sec theta. So if you are substituting the value of theta as 45 degree, then hydraulic radius r equal to y divided by 2 root 2. So this is the condition for the most economical or efficient section of the channel. Now the session comes to an end. For the time being, it is enough. In the next class, we are discussing about. Thank you for your patient listening. Please don't forget to press the bell button to get the notification of next video. See you, your SumamMiss.